Okay, so logarithms. Now, with logarithms, the only thing about these is really we want to change an index form into this logarithmic style, and it's just another style to write index notation, and it's going to help us later on when we're trying to find specific parts that aren't going to be straightforward. So what we're going to do for the first lesson is we're just actually going to practice changing between logarithm and index form, and then we're going to see later on why this is useful, okay? So, let's say, for example, we had 3 to the power of 2 is equal to 9, something nice and easy. Well, we can rewrite this in logarithmic form, okay? So, to do so, we're going to start off by writing log, and we're going to be using the next number that we're going to write is the base of our power. So our log is base 3 because the index that we're writing it from is 3. Now the next number we're going to use is the answer that we actually want to get. So we're basically saying we want log base 3, so the base of 3 that gives me an answer of 9. So essentially this is asking 3 to the power of what is giving me 9, okay? 3 to the power of what is giving me 9. That's what this log part means. And we know, well, 3 to the power of 2 is what gives us 9. And this is how we write it in logarithmic form. So this is just another way of sort of asking the question, well, 3x is equal to 9, okay? And we know, or we have ways of solving these exponential equations to get an answer. But they're not always going to be whole numbers, okay? So we'll be seeing some more of non-whole numbers later on in this topic, but for now we're just going to practice changing the different forms, so rewriting these forms, okay? And these are interchangeable as well, okay? So if I have the log form, I can go back to index form, and if I have the index form, I can go to the log form. So in general, the general way that we write this is if we have not y, I'm going to do it this way, x is equal to a to the power of some y, so say 3 to the power of 2 is equal to 9, okay, we can rewrite this as the log of that same base a of x is equal to y. And this is the sort of general form of our equations, okay, so this is the general form of our logarithmic equation where we can go back and forth between our logarithm and our index, okay. So what we're going to do is we're going to be looking at a few examples that's just practicing changing between these two. So let's start with 4 to the power of 3 is equal to 64. So to do so, we're going to write this as log of that same base. So again, it's the 4 because the base of our power is 4. So the base of my log is also going to be 4. But it's going to be the log of base 4 that gives us the answer of 64. So what power gives us 64? And we know, well, that must be 3. Okay? So log base 4 of 64 is 3 because 4 to the power of 3 is equal to 64. Continuing on with this one, so part B, it's the same sort of thing. Okay, so it's going to be log with my base of 2. And it's what gives me 1024. And we know, well, 2 to the power of 10 gives us that. Okay, and as I said, we can go the other way as well. So where'd that 4 come from? It's interesting. If I've got the logarithmic form, we can change it back to the index form as well. Okay, so the log base 3, so my 3 is my base for this power again. And it's saying 3 to the power of what gives me 81? Well, my answer is 4. 3 to the power of 4 gives me 81, and that's all it is, okay? Now we need to, the next part of this question actually says then state whether it is true or false. So is 3 to the power of 4 equal to 81? Well, let's put it in. 3 to the power of 4. Yes, that is. So therefore, log base 3 of 81 is equal to 4 is a true statement, okay? So this is a true statement. Okay, part B. Now part B is log of base 5 of 4 is equal to 500. So let's just quickly rearrange this. So my base is 5, and this is saying 5 to the power of 500 should be equal to 4. Now, is this true? No, it's not. So therefore, log base 5 of 4 is not equal to 500, and therefore not true. Okay. So this is our statement for our index. Okay, it is not a true statement, just like the others. Okay, and so with that, that leads us to our last bit, where we are going to deal with some logs that aren't as nice. So solve each logarithmic equation by changing it into an index equation. So when we've been giving a log equation like this, we're actually going to rearrange it back into index form before we actually solve it. So we get x is equal to log base 4 of 1 over 16. Okay, so again, my base is the same. My base is the same, and Siri needs to stop listening to me. It's starting to get really annoying. 4 is our base, and we're saying what? 4 to the power of what is equal to 1 on 16. Okay, so 4 to the power of what is equal to 1 on 16. So now we can solve this just like the exponential equation we had in the previous video. So 4 to the power of x is equal to, well, 1 over 16 is the same as 1 to the power of 4 on 2, which is the same as 4 to the power of negative 2. So therefore, x must be equal to negative 2. Okay, and we know that's true. So if we were to put log of 4 of 1 of 16 into a calculator, that could do it for us. Mine one actually can. Your one might not be able to. But log 4 of 1 on 16. Okay, and there we go. It's negative 2. So perfect. Okay, part B, we've got a little bit different. Okay, so this one says, okay, so 1 over 6 is equal to log base 2 of x. So what this one is saying is, okay, 2 to the power of 1/6 is equal to x. Okay, so 2 to the power of 1 on 16. Well, that's easy. We can just put that one straight into a calculator. 2 to the power of 1 over 6. That's equal to something really disgusting. So x is equal to 1.1224 ... Okay, so that is a really gross number. But when you rearrange it, and it is just something as easy as 2 to the power of 1 on 6, you can just, rewrite that as, put it into a calculator. Or alternatively, we know that 2 to the power of 1 on 6 is just the 6th root of 2. Okay, so we can rewrite it like that as well, using our index notation and our fractional indices. Now the last one we've got, okay, is log of base x of 343 is equal to negative 3. So this one's saying, okay, well, x to the power of negative 3 is equal to 343. So what does x need to be? Okay, so to remove a negative 3, okay, we could do the cube root of the negative, or the negative cube root of 3. I'm not actually sure if that works, so let's try it on the calculator and see if it does. It's not something I've ever tested. So shift and the power button, you can put negative 3 in here, and 343, okay, oh, there you go, it's 1/7. So we can just rewrite this as x is equal to the negative cubed root of 343. So x is equal to 1/7. Use your calculator if you can, makes it easy, okay? And that's our final answer. So we'll come back and we'll have a look at using the calculator and some other stuff to work out what our logs are going to be, okay? So with that, I'll join you in the next video.